Okay, so I made up a little table for thin lenses. Remember, for a converging lens, the focal length is positive. R1 will be positive where R2 will be negative. That's the radii of curvature. If the object distance is greater than the focal length, right? If the object is outside the focal length, then we'll have a positive image distance, which is associated with a real image. And real images form on the opposite side from the object on lenses. On the other hand, if the object is inside the focal length, right? If the object distance is less than the focal length, then you'll get a negative image distance, which is associated with a virtual image. Virtual images form on the same side as the object. Okay. For diverging lenses, they have a negative focal length, a negative R1, and a positive R2, which will always produce a negative image distance, which is associated with a virtual image. And again, remember, virtual images form on the same side as the object. All right. So for our sample problem, what we've got is we're told we have a converging lens, and there's the object distance is plus 16 centimeters, and it has a magnitude of the focal length of 6.6 centimeters. Now, we're told that the magnitude is 6.6, but what is the sign of that? Well, for a converging lens, remember, a converging lens has a positive focal length, so we're going to write that as plus 6.6 centimeters. All right, and then now we're just going to go through and sort of find all of the stuff we want to find. It's about the image. We want to find the magnification, the type of image, that kind of thing. So our formula is 1 over the object distance plus 1 over the image distance is equal to 1 over the focal length. We don't have to worry about the other side where it talks about the various radii of curvature, because we already have everything we need here. So I've got a positive. The object distance is always positive, at least for one lens. So we have 1 over 16 centimeters plus 1 over the image distance is equal to 1 over 6.6 centimeters. Before I give you the calculation, we should be able to know that what type of image this will form, right? If the object distance is greater than the focal length, then we get a real image. So we should end up with a positive number here for our image distance. All right, turns out that's true. We end up with an image distance of 11.2 centimeters when we plug that in. It's positive. Okay, so that positive image distance means it's a real image. Okay, that's information we need. Where does that real image form? Well, for lenses, real images form on the opposite side from the lens, right? So opposite side. And it asks for the magnification. Magnification is equal to the negative of the image distance over the object distance. We plug that in, plug those numbers in. That's a 11.2 centimeters over a 16 centimeters. Don't forget your negative sign. And we get a magnification of negative 2.7. Okay? So that means that the image is going to be 2.7 times greater than the object. It's going to be larger. And the negative means that the image will be inverted. Okay, so remember, when you go through these problems, remember though, if it's a diverging lens, they're always not necessarily always going to give you the sign. So converging lens, you got a positive focal length, but a diverging lens, got to make sure you make that a negative focal length, okay? All right, y'all, I hope you have a great rest of your day. Take care.